All right, this is cycle 3, guided notes, and in this cycle we're going to talk about the distribution of data. And so when we look at a histogram or a box plot or a dot plot, we want to be able to tell, how is this data distributed? Is it skewed in a certain direction, or is it not? And so we have 3 vocabulary words, or 3 types of description of data that we're going to look at on this first page. So this very top one, when you have graphs that look like these 3 examples, it's called a symmetric. So these graphs are symmetric. This is when graphed, a vertical line can be drawn at the center and it will form mirror images, with the left half of the graph being the mirror image of the right half of the graph. In the histogram and dot plot, the shape is referred to as a bell shape. Now, it doesn't necessarily have to be perfectly symmetrical. If you have a distribution of data and it looks fairly symmetrical, then you would know that it's not skewed either way, and that you could say it's fairly symmetrical. For it to be perfectly symmetrical, the left and the right would have to be mirror images of each other. But sometimes data can still kind of be symmetrical, more symmetrical or closer to being symmetrical than it is being the other 2 options that we'll talk about below. So this first fill in the blank right here, you're going to write symmetric. So symmetric, again, is where basically the left and the right are mirror images. It kind of creates this mound. I always think of like a roller coaster. So this is just like one hill and you're done. And so you go up and you go down, and that's it. There's no kind of longer track that you're riding on. It's just up and over. Okay, so for the next option, when you look at distribution of data, so we have these 3 examples. And if you notice, these examples kind of go towards the left a little bit. I wish this was called left skewed, because to me, all the data is on the left, and that makes sense, and so it's skewed left. This actually means that it's skewed right. This means that fewer data plots are found to the right of the graph, meaning in this first example, this histogram, let's say that these were test scores. So fewer kids scored 70 than they did 10. So there's kind of this tail of data. And the graph is pulled toward the higher positive numbers or to the right. So most of the data is to the left of the graph, but we call this right skewed or skewed right. So we're going to put right up here. So when we say that something is right skewed, it looks like the data is all to the left, like the higher peaks are to the left. On a box and whisker, the box is more to the left, but that actually means that it's skewed right. And going back to kind of the roller coaster analogy, I always start where like your hill is going to be. And so on this one, if I start where my hill is, I go up the hill and I go down to the right. So wherever you go down, that's the skew. So if I start up on the hill and I go down to the right, then I know it has to be right skewed. On a dot plot, I go up the hill and down to the right, so I know it's right skewed. Even when you look at a box and whisker plot, this is your track, this is your hill, and you go down to the right. There's a longer tail right here to the right, so we know that it's right skewed. There's this long tail, and that tells you that it's right skewed. Okay, so let's look at our last 3, and you can probably guess what it is, especially because it says right here. So we have this type of skewness is when fewer data plots are found to the left of the graph toward the smaller numeric values. The tail of the graph is pulled toward the lower negative numbers or to the left. So in this case, most of the data looks like it's pushing to the right. And so if we go with the roller coaster example, we want to go up the hill and we go down to the left. Up the hill, down to the left. So wherever we go down, that's the skewness. So if we're going down to the left, that means this is left skewed. Even on a box and whisker plot, we can go up the hill and we go down to the left. There is a longer tail on this side than there is on this side. So the left side is longer, it's more extended, there's a tail, and so that's when we say that this data is left skewed. So this next page, there's nothing to write on this page. I just put it in here strictly as a reference guide for you. So as you're working through your practice problems, you can refer back to this reference guide, and I've given you a few examples of what skewed data looks like. So on this left column right here, we have these three graphs are good examples of what left skewed look like. If you think of the roller coaster, they go up and down to the left, up and down to the left, up and down to the left. So they're left skewed. If you look at these next example, let's look over here on this third column. This goes up and down to the right, up and down to the right, up and down to the right. So these are right skewed. And then in the middle here, you have data that is fairly symmetrical or exactly symmetrical. So this one right here is symmetrical. The left and the right are complete mirror images. Same with this one. This one is a little not as perfectly symmetrical, but it still kind of has the peak in the top, in the middle, and we go down evenly on both sides. So there's not a really distinguishable tail. And so it kind of still looks like a mound. So we say that it's mostly symmetrical. So again, this is just going to be used as a reference so that you guys can have it to help you answer any future questions as we're working through this concept. What did this say down here at the bottom? This data represents test score. So now that we have this understanding of what it is, we've been working on how to create stuff and how to now determine if it's skewed or to understand the distribution. So with all of that knowledge, you are going to apply that to these two kind of open-ended questions. So we're going to work on the first one together. You can try to do this one on your own and then look at what I did, or you can follow along with me. You are going to do the second one on your own, and I'm going to check that in class. So if this kind of seems intimidating, this question, then maybe you want to follow along really closely with me, pausing the video or rewinding, just so that you fully understand the process and what I'm doing. I'm going to do it fairly quickly because you can pause or rewind to kind of hear it a second time. So as always with data, we need to write this data in order. So I'm going to make this a little bigger, and we're going to write this data in order from smallest to biggest. So we have 23 and 31, 32, 33, and 99. Okay, so this one right here should be 97. Okay, so let me just double check and make sure I have all of the numbers. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're given 15 numbers. Let's make sure I have 15 of my data that I rewrote. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. Okay, so we're going to use this data to create a histogram and a box and whisker plot. So in order to create a histogram, I'm going to do a really kind of sketch of a frequency table. And on this side, I see that my lowest is 23 and my highest is 99. So I'm going to do 21 to 40, 41 to 60, 61 to 80, 81 to 100. Oops, sorry, that's kind of hard to see. Okay, that's 100. Sorry. All right, so this is our frequency table. So we have 21 to 40, 41 to 60, 61 to 80, and 81 to 100. Okay, so now we have to do some tally marks. Okay, again, this is a really rough sketch, so maybe make yours a little bit neater. So for 21, the number 23, we have 1. Number 31, we have 1. 32 is still between 21 and 40. 33, 45 is not, so 45 jumps down here. 54, 54, 55, 58, 67, 76, 79, and 96, 97, 99. So we have 4, and 5 is 9, 10, 11, 12, 13, 14, 15. So I'm constantly checking that I have all of my numbers. So now I'm going to put over here how many I have. So I have 4, 5, 3, and 3. Great. So let's make our histogram. So down here we have 21 to 40, 41 to 60, 61 to 80, and 81 to 100. And at the top, I know I'm only going to 5, so it's just going to be 1, 2, 3, 4, 5. That's fine. This is my frequency. You should write that word out. And this data represents test scores. So down here at the bottom, we can put test scores. You should write that out. I just don't have enough space. And now we're going to make our bars. So for the 21 to 40 range, we're going to go all the way up to 4. Let me fill that in. And for 41 to 60, we go up to 5. And fill that in. And 61 to 80, we have 3. And 81 to 100, we have 3 again. So this is our histogram. So if we had to decide if this was right or left skewed, right now it looks like we kind of have a hill here and then it goes down. So I would say since our lower amounts are to the right and our hill is to the left, our tail goes to the right, we're going to say that this is fairly right skewed. It's not really evident and really dramatic, but the lower values, the lower data points do kind of go off towards the top. Especially if I maybe put some more intervals on there, there would be none. And the hump is, the hill is more towards the left. So we're going to say that this is right skewed. So really fast, just to make sure we answer the whole question, it told us to make a box and whisker plot. So let's make that box and whisker plot up here really fast. So I need to know my median, but I'm just going to label these 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Make sure you label underneath those because that's important too. I just don't have a lot of space right here, so I'm not going to label mine. But you need to write 100 underneath and 90 and etc. Okay, so for our median, we're going to go 23, 99, 97, 31, 96, 32, 79, 33, 76, 45, 67, 54, 58, 54. And we have 55. So 10, 20, 30, 40, 50. 5 is right about here. That is our median. So our min is 23. So 10, 20, 3. Our max is 99. That's really close to 100. Our quartile 1 is the median of our first half. So 54, 23. 54, 31, 45, 32, 33. So 10, 20, 33. And then our quartile 3 is our upper half. So 58, 99, 67, 97. Where was I? Okay. 76, 96 and 79 is our median of the upper half, our quartile 3. So 10, 20, 30, 40, 50, 60, 70, 80. So right here at 79. Let's draw our box. And again, this one's kind of tricky because it's not really a dramatic one, but there is a bit of a tail going to the right. There is more data kind of hanging out over here. So we say that we go up and down to the right. So again, we're going to be right skewed. We can tell because there is more data towards the left. There is a tail going towards the right. So you want to make sure you write how you can tell. How you can tell. How you can tell. We can tell by the tail. Okay, so for this second question down here, I want you to do this on your own, and I will check it in class, and I will see you there.